Alright, so this is 9.1 sequences in series, day 1. So we're going to start by defining a sequence. A sequence is an infinite sequence is a collection of numbers such as A1, A2, A3, AN, called terms. So these are called terms. A1 is the first term, A2 is the second term, A3 is the third term, A to the nth is the nth term, and a finite sequence is a finite collection of terms. So that could be 10 terms, 11 terms, 20 terms, but not infinitely many terms. Example number 1 says, writing the first 4 terms of the sequence given by an is equal to 3n minus 2. So we're going to find the first 4 terms. So you have A1. All you're going to do is plug in 1. 3 times 1 minus 2, that gives us 1. That's our first term. A2 is our second term. Plug in 2. That gives us 6 minus 2, which is 4. A to the 3. 3 times 3 minus 2. That's 9 minus 2, which is 7. A to the 4. The fourth term, which is plugging in 4. That gives us 10. So the first 4 terms are 1, 4, 7, and 10. Okay. Then this next one says this sequence alternates signs. Write the first 4 terms of the sequence. So I'm going to go ahead and start off with plugging in 1. That's still the first term. So then this is going to be -1 to the first power is -1. And then on the bottom we have 3. Okay, then A2, plugging in 2. So -1 squared is 1 over 2 times 2 plus 1. So that's 5. Okay, then A to the third, that's plugging in 3. That's going to be -1 to the third, that's a -1. And then on the bottom here we have 7. And then lastly, A to the 4, I'm actually going to just look at the pattern, see how it went from -1 third, 1 fifth, and then 1 seventh. I know that the next one has to be positive, and then on the bottom you're increasing by 2, so it's 1/9. Alright, so actually let's write the first 4 terms out. Alright, so given the first 4, a recursive formula, you were given the first term and a formula that relies on the previous terms. So example number 3 says, write out the first 5 terms of A1 is equal to 3 and AK is equal to 2, AK minus 1 plus 1, where K is greater than 2. Alright, so let's go ahead and plug in the first 5 terms. So A1 is 3, then A2 is 2 times the previous one, which is 3, and then plus 1, so that's going to give me 6 plus 1, which is 7. Then A to the third is 2 times 7 plus 1 equals 15, because that was the previous one. Then A4 is 2 times the previous one, which is 15, plus 1, that gives me 31. And then A5 is 2 times the previous one, which is 31, plus 1, so that's going to give me 31 times 2 is 60, plus 1, 63. So my first 5 terms are 3, 7, 15, 31, and 63. Alright, the next thing is factorial notation. So let n be positive integers, then n factorial is 1 times 2 times 3, n minus 1 times n, and then we have a special case, which is 0 factorial is equal to 1. Okay, so basically n factorial is just all the numbers multiplied up to that n. Okay, and then we're going to write out the first 5 terms of the sequence given by an is equal to this formula right here. So we're going to plug in 1, 2 to the 1 over 1 factorial. That's going to be 2 to the first power is 2. And then 1 factorial is just 1. So that's going to be 2a to the third, 2 to the second power, and then 2 factorial. So that's going to be 4 over 2 times 1. So that gives you 4 over 2, which is 2. Then you have a to the third, 2 to the third, 3 factorial. And then that's going to be 8 over 3 factorial is 3 times 2 times 1. And notice I'm going backwards. It's just easier for me to count backwards. Okay, so then this is going to be 8 over 6, which is 4 over 3. Okay, then we have a to the 4. That's 2 to the 4th over 4 factorial. So that's going to be 16 over 4 times 3 times 2 times 1. And then I'm going to multiply all that out. 24. And then I'm going to simplify this. So I'm going to divide both of these by 8. Okay, and then that would be our answer. All right, a to the 5th is the next one. So 2 to the 5th over 5 factorial. That's going to be 5 times 4 times 3 times 2 times 1. And then on the bottom, 2 to the 5th is 32. Okay, then I'm going to try to do this strategically without using a calculator. So I know 4 and 2, that's 8. And I know 32 divided by 8 is 4. So these cancel out and you get that 4 left. So your answer would be 4 over 15. Now you could also just multiply it all out and then divide it. Alright, so my sequence here is going to be 2, 2, 4 thirds, 2 thirds, and 4 15ths. So that's what my sequence of 5 terms is. Alright, next thing we're going to do is simplify the factorial expressions. Now if we were actually in class, this would be more like a no calculator section, but these are more for fun per se. So 8 times 7, 6, 5, 4, 3, 2, and 1, that's 8 factorial. And then you have 2 factorial, which is 2 times 1, and then 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. Okay, and then what you would do is basically you could cancel out these 2's, cancel out these 3's, cancel out these 4's, cancel out these 5's, cancel out these 6's, the 1's cancel out, and then you're left with 8 divided by 2, which is 4, so you're just left with 28. See, wasn't that fun? Alright, the next one, you actually can't do this on your calculator, but we're going to go ahead and try to expand it. Now, n factorial is going to be n times n minus 1 factorial times n minus 2 factorial, all the way until we get to basically 1. So those numbers are all being multiplied out. Okay, and then on the bottom here, n minus 1 factorial is n minus 1 times the next lowest one, n minus 2, times all the way down to 1. So basically, this all right here is going to cancel out, and you're just left with n, and that's it on the top. An alternative way of doing this, so method 2, would be you could rewrite the top n factorial as n times n minus 1 factorial, and then leave the bottom as n minus 1 factorial, and divide that out, and you get n. So basically, I could, the reason why this works right here is because if, let's say you take, I'm gonna scribble this out, let's say you take 4 factorial, well, that's the same thing as saying 4 times 3 factorial, because you would basically be able to expand 3 and still get 4 factorial.